Good morning friends, welcome back to Parnika tutorials. In the last video, I have discussed what is a collection, what is a collection framework, what is the need for a collection framework. I hope you have watched that video. If you did not watch that video, I sincerely request you to go back and watch that video and come back to this video. In this video, I want to discuss about the collection framework hierarchy, then I will discuss about the set interface and the implementation classes such as Hashset and LinkedHashset. First, let me discuss about the collection framework hierarchy. Here you will have the class, interface and extends property and then implements property. Now look at here, the green one are the interface and the black one are the classes. So you have the parent interface, which one we will call it as an iterable interface. So this is the super interface or the parent interface or the root interface. Now the iterable interface, or I can say the collection interface, extend the iterable interface. So I can say iterable interface is the parent interface and then collection interface is the child interface. And then from the collection interface you have the list interface, queue interface and then set interface. Now in the list you have the implementation classes such as ArrayList, vector, linked list. Similarly, for the queue interface you have the child interface which is DQ and the implementation classes such as ArrayDQ and then priority queue is there. For the set interface, you have the implementation classes such as Hashset and LinkedHashset. First, let me discuss about the set. Okay, what is the set is that, as usually, set is a collection of objects. But the beauty about the set is it does not allow the duplicate elements. Okay, when compared to the list, the set does not allow the duplicate objects, whereas list allows the duplicate object. Okay, so this is about the set. Set is a collection of objects, but however it will not allow the duplicate objects. Now let me discuss about the Hashset. How the properties of the Hashset, first let me discuss. Okay, Hashset. Now as usually, as it is comes under the set, it does not allow duplicate objects. It does not allow duplicate objects. And another important point is that order, or I can say it does not follow any order. Meaning is that if the objects are there, we cannot say when we are displaying the list of objects, we will not get them in a proper order. Okay, and it permits the null value. Means null value is also possible in the Hashset, and it implements, as I said earlier, Hashset class implements the set interface. Okay, the Hashset and LinkedHashset implements the set interface, and then underlying data structure means what data structure the Hashset will use is that, let me write it. Underlying data structure is hash table. Okay, it uses the hash table data structure. Objects are inserted based on hash code. Inserted based on hash code. I think everyone know what is a hash code. I have discussed about a hash code in one of the videos. So what is the data structure it uses is, it uses the hash table. So that's why it is not allowing any duplicate objects. And if you talk about the initial capacity, meaning is that how many objects you can store in a hash set is, we can able to store 16 objects. Okay, and then load factor, this is very important. Load factor is 0.75, meaning is that out of the initial capacity 75% objects are already filled. Out of 16, what is the 75% is 12. So if 12 objects are already filled, then the hash table size will be doubled. Is it clear? So if you are keeping the initial capacity, means by default the initial capacity is 16, so you can able to store 16 objects. Okay, if it does not specify any size, then load factor is 0.75, meaning is that once 75% of objects are filled, then hash table size will be doubled. Okay, then how can you create the Hashset is Hashset. Okay, you will specify Hashset and then object h new Hashset. Okay, if it does not provide anything, then it will consider the initial capacity is 16 and load factor is 0.75. However, if you want to change the initial capacity, then you can write Hashset. Okay, and then you can write h is equal to new Hashset, and then you can provide the an integer variable, means the data type, and you can provide the initial capacity, means whatever the capacity you want to provide. Suppose if you want to provide initial capacity as 1000, then meaning is that you can able to store 1000 objects. However, the load factor will be still 0.75. But if you want to change the initial capacity and also the load factor, then you can change like this Hashset, and then you will provide the object, then you will write new Hashset. Okay, I'm really sorry, you should use the Hashset like this. Okay, so then you can provide like this. What you can provide is that you can provide the initial capacity, and also you can provide the load factor, okay, which is a float variable because it is a real number. So you can accordingly you can change it. I hope you have understood what is the Hashset, the theoretical concept. Now let me practically implement this one by writing some program. Okay, so I will go to the desktop, Java programs. Okay, let me click it. Now let me click the new text document, and I will say Hashset example dot java. Okay, now let me open this one using the notepad++. So what I will do is that I will write a small program. You know that this collection framework, the classes and interfaces are there in the package called java.util. So you have to import java.util package, okay, where Java is the what you call the package and util is the sub package of the Java. And then I will write class Hashset example. Okay, then what I will do is that I will write public static void main, then I will write string args, and then I will open the main, and then I will write Hashset, and then I need to provide the data type. So I need to provide string. Even if you don't want to provide the data type also, it is not a problem. So I will write Hashset and then a data type, and then I will write names or something you can write is equal to new Hashset. Okay, and then you can provide the string. Okay, and I'm not providing any capacity, so the initial capacity will be 16 and the load factor is 0.75. Now we have certain methods in the Hashset. What are the methods are? You have an add method, you have the remove method, and you have the clear method, contains method, is empty method, size method is there. So we have totally 6 methods are there. One is add method, okay, and then you have the remove method. Similarly you have contains method, and another one is that you have is empty method, okay, as it is a method, let me write it, and then you have the size method, and then you have the clear method. What is the use of these methods are, if you want to add some object, then you can use the add method. If you want to remove any object, then you can use the remove method. You want to verify whether a certain object is available or not, then you can use the contains method. You want to verify whether the set is empty or not. If you want to verify, you can use this method. If you want to know how many objects are there, then you can use the size method. If you want to clear or remove all the objects, then you can use the clear method. Okay, so let me discuss about all of them one by one. Okay, so what I will do is that first I will verify whether the set is empty or not. Okay, look at here how I will write. I will verify whether is the set is empty or not. How can I verify? I will simply write names dot, okay, is empty or not. We will see whether is it empty or not. Okay, so what I will do, I will write simply system.out.println. Okay, I will write system.out.println, and I want to verify is it empty or not. As there are no objects till now, I can clearly say it is empty. However, we will run this program. So I will go to the command prompt, and then I will go to the desktop, then Java programs, okay, and then I will write here, what is that? I want to compile the Hashset, okay, example dot Java. There are no errors. Let me run the Hashset example one. See, we got true. So meaning is that this set is empty. There are no elements. If there are no elements, then it will return the true. If there are some elements, then it will return the false. So it will return either true or false. Okay, let me remove this one so that we can use the space effectively. Now if I want to add some elements, then what I can write? I can write names dot add. I will write Parnika. Means I am adding an object called Parnika. Similarly, I want to add the another one is tutorials. Okay, then I will add Java. Okay, and then I will add course. Okay, so these are the objects I have added. Okay, now if you want to display all of the objects, then you can simply write system.out.println. Okay, simply you can write names, then you can see the set will be displayed as an output. Okay, having the objects as Parnika, tutorials, Java course, but however the order will not be the same. It can give in any order. Okay, look at here. Let me compile the program again and let me run the program. See, we got the Parnika. After that we should get tutorials, but it got Java, then tutorials, then course. Okay, so that is what the point. Even you have inserted the objects as Parnika, tutorials, Java course, but as it is a Hashset, it will not give them in a proper order. Now if you want to know how many elements are there, then you can find the size. How you can write? You can say the number of objects is, I will write plus, and then I will write names dot size. Okay, let me save this one and let me compile the program again and let me run it. Okay, now you can see the number of objects are 4. Like you have Parnika object, tutorials object, Java object, course object. Okay, similarly if I want to remove anything, then what I will do, I will write names dot remove which one I want to remove? I want to remove the course. Okay, after removing the course, I want to find out how many objects are there. Then I will write system.out.println the number of objects is, I'll give space, then concatenation names dot size. Okay, then similarly I want to now verify whether is the hash set is empty or not. Okay, how can I do? I can simply write system.out.println names dot is empty. How many objects are there? 3 objects are there, so I can say it is not empty. If it is not empty, we'll get the output as false. Okay, let me save this program and compile it, and now let me run the program. Now you can see the number of objects are 3 and we got the is empty is false. So I can say we have successfully removed the object called course from the set. Okay, similarly if you want to clear everything, then what I will write? Names dot clear. Then I will verify whether is the set is empty or not. After removing all of them, obviously the set is empty, so it will give the output as true for you. If you want to verify, let me compile the program and now let me run the program. Okay, see, we got the output as the number of objects is 3 and then false. After clearing everything, the elements are not there or the objects are not there, so that's why we got is empty is true. So I hope you have understood how to add the objects, remove the objects, clear the objects, and now I want to verify is it contains or not. So what I will write is that system.out.println, okay, names dot contains. What I want to verify is, let me not remove, okay, or clear. Okay, now I want to verify is Parnika is there or not. Parnika object is there or not. Is Parnika object is there? Yes. Then we will see whether we will get the output or not. If we get the output, what will be the output also we will verify. Now you can see the number of objects are 3 and then we got the false. Finally we want to verify whether Parnika is there or not. Yes, Parnika object is there, so that's why we got the output as true. Okay, so let me remove all of them and I want to verify one more thing. What is that? Already we have added the object Parnika tutorials Java course. Again, if I am adding the course, then what will happen? Okay, because just now we have discussed that set will not allow the duplicate elements. Now I will write system.out.println and I will simply write names. Now you can see, we can see the course will be displayed only once. Let me compile the program and let me run the program. Okay, see, even we have added the course twice, but it has taken only once. That's meaning is that it will not allow the duplicate objects. Okay, now if you want to display all the objects one by one, then you can use the either the iterator or the for each. First let me discuss how can you do with the help of for each. So I will write for and then you will write some variable which is a string variable and then you will write on which list you want to do or on which set you want to do. Okay, on the set called names, I want to traverse one by one and I want to display. Or if I want to add something like I can write string some new value is equal to, I will write welcome, something I am writing welcome, then I will do the concatenation and then I will add n, then I will display, okay, I will display the new value. So I will write system.out.println and here I will display the new value. Now you can see, let me close the for loop. Okay, now I have saved. Then let me compile the program. We got an error. Why? Because we did not end with a semicolon. Let me save this one, and now let me compile the program. There are no errors. Let me run the program. Now you can see, welcome Parnika, welcome Java, welcome tutorials, welcome course. So on each object you want to do certain thing, then you can do it, okay, by the help of for. So you will write for on each a object, which is a string object, and then you are writing on which set you want to do and what operation you want to do. So even you can simply display them also. How you can simply display? You can write system.out.println, you can write n. Okay, then look at here. Let me save this program and compile it. Okay, Java C has set example.java, then Java has set example. See, you got Parnika, Java, tutorials, course. So instead of displaying them, earlier we are displaying them as a set of objects like this. You got the braces and then Parnika object, Java object, tutorials object, course object. But now we are getting as an individual objects. Parnika one object. In the next line you got the Java, next line tutorials, next line course. So what it will do, it will take each object and store it in the n, and then we are displaying the n. Even you can do the same task with the help of iterator also. Okay, so what I will do, I will write iterator, okay, and I will take the string, and then I will write something, new names is equal to names dot iterator. Okay, and then I will write while new names dot has next. What it will do is that whether the next element is there or not, you have two methods called has next and next. What has next is do is that whether the next object is available or not, and if it is available, if you want to display the next object, then you can use the next. Okay, so has next will verify whether the next object is there in the set or not. If it is available, then what I will write, string n is equal to new names dot next. Okay, you have to use the next method, then whatever the next object is there will be stored in the n, and now you are displaying the n. So I will write system dot out dot println, and then I will write n. Okay, now let me close the while loop, and now let me save this program and let me compile it. There are no issues. Let me run it. Now you can see whatever the task earlier we have done with the help of for, we have done the same task with the help of iterator also. So the iterator will have two methods. One is has next and next method. What is the purpose of has next method is it will verify whether the next object is there or not. If it is available, if you want to display, you can use the next. So next object will be displayed. So what it will do is that in the new names, whether the next object is available or not, it will verify. If it is available, it will get true. Then what are the statements which are there in the while loop will be executed. If there are no objects, then it will become false. If the while condition is false, the statements which are there in the while loop will not be executed. So I hope you have understood the theoretical concept behind the Hashset and what are the various methods are there and how to work with that one. So let me discuss again about the Hashset. It does not allow the duplicate elements. However, the order is not followed in the same way whatever you have added the elements, and it permits the null value also. If you want to verify, let me give the null value. Okay, we want to verify whether the null value permits or not. Let me remove this statement, and then I will try to display the objects using the iterator. Let me compile the program, and now let me run the program. Okay, Now you can see we got Parnika, null, Java, tutorials. Now let me discuss about the linked hash set. We have already discussed about the hash set. Now let me discuss about the linked hash set. What is the difference between the linked hash set and hash set is, even linked hash set class does not allow duplicate objects, but however it follows the order, whereas the hash set does not follow the order, but this one follows the order. It follows the order, means whatever the way you have added the objects, in the same way it will be displayed, and it permits the null value. It implements the set interface. Underlying data structure is hash table and even the double linked list, and inserted based on the hash code. Initial capacity will be 16 and load factor is 0.75, and then if you want to create, you can create like this. What is the way is linked hash set, okay, linked hash set, you have like this, you have a class linked hash set. Let me remove this one, and then you can write like this, linked hash set some object is equal to new linked hash set. If you are not providing anything, then initial capacity will be 16 and load factor will be 0.75. However, if you want to change the initial capacity, you can do like this. If you want to change the linked hash set initial capacity and also the load factor, then you can change like this. You can provide the initial capacity and also the load factor. Only the difference between hash set and linked hash set is linked hash set follows the order, whereas the hash set does not follows the order. Now let me write the program for it. Okay, so what I will do, I will change here only. Okay, so instead of hash set, here I will write linked hash set, linked hash set. Okay, some names is equal to new linked hash set I will write. Okay, now I am adding the elements. Let me see what will happen. Will it display in the same order or not? You can verify. We have added them in the Parnika, tutorials, Java and null. Remaining things will be same as hash set. Let me compile. There is no issue. Let me run the program. Now you can see whatever the way we have added the objects, the same way it has displayed. Parnika, tutorials, Java, null. Remaining methods are same. Like you can use the remove method, you can use the is empty or not size method, and then you can use the contains method. All these things you can do. If you want to verify, I can write names dot remove. I will write Parnika. Okay, and then I want to verify is it empty or not. If names dot is empty method I will use. If it is not, if it is empty, then what I want to display, I want to display as empty. System.out.println, I can simply write empty. Else I want to find the number of objects. So I will write system.out.println the number of elements or the number of objects. Number of objects is, I will write plus names dot size method I will use. Let me save this program and let me compile it. Okay, Java C Hashset example.java, then I will write Java Hashset example. You got the number of objects is 4. How we have 4? We have asked to remove the Parnika. Is it removed or not? We will verify. Okay, so here I will write system dot out.println. Okay, and then we can write here names. Let me save it. Let me compile the program and let me run the program. We still have Parnika tutorials. Okay, what is the issue we have done? Can you verify? Because when we have added the object Parnika, we have written it as capital P, but here we are trying to remove small p. So the case sensitive, Java is a case sensitive, so that is why it is happening. Now let me compile the program again. Let me run the program. Now you can see the Parnika object has been successfully removed and the number of objects is 3. So I hope you have understood the linked hash set and then hash set. Only the difference between the linked hash set and hash set is hash set does not follow any order, but however linked hash set follows the order. I hope it is clear. If you still have any doubts related to this concept, feel free to ask me in the comment section. I will try to clear your doubts as early as possible. Thank you for watching the complete video. Have a nice day.